Perfect. So what we're going to do today is we're going to be using Excel to calculate standard deviation. And then we're going to go into some detail regarding the standard deviation near the end. So the way that we're going to set up class today is I'll show you guys how to do the Excel calculations for standard deviation of a sample. And well, I'll show you population as well, but we won't be using that today. But I'll show you guys how to do that. We're also going to be calculating average, but since we did that last week, I'll still show it, but I won't spend as much time on it. And then after doing some of those problems together, then we'll move forward to the final questions. You will still need to submit the activity in its entirety, but for the demo that I'm going to do today, I will not be finishing it, but you guys will when you submit it like you would any other assignment. Okay. So let's get started and see first. Hello, my cat is here. Hello, Petunia. Let's take a look at what this activity even is to begin with. So we have, here it is in class activity 2. This is in our week 4 module for variability. This document as well as the Excel document are both in the submission link for in class activity 2. So it says a researcher wanted to determine what the most feared crimes were among college students. To obtain some data, they sampled 116 of their students to rate their fear level for the following crimes: hacking, panhandling, assault, having their home broken into when you're not home, murder, being conned, robbery, vandalism, having your home broken into when you are home, and car theft. So for each of these crimes, each participant rated their fear on a 1 to 10 Likert scale, where 1 representing having no fear and 10 represented being incredibly fearful, the most fear they could have. So what I'll be asking you guys to do, and again, what I'll show you for some of it, but not all, but you will need to complete this in its entirety, is to calculate the mean and standard deviation for each of the crimes. So here we have hacking. I already have this up for you just as kind of a little preview, a little example. Then there's panhandling, assault, break-in while away, murder, pretty much all the crimes that were listed in the example above, all the way down to car theft. And lastly, what I really want to focus on today as far as class is concerned are these questions here. We won't be able to answer these 2 questions because that'll be done with finishing all of the assignment. And I'm not going to do that with you today. I'll just show you how to do the Excel portion, but we're certainly going to focus on these 2 questions. How would the variability of all crimes change if we were measuring a population in Y? And then the range of each crime is 9, yet all the standard deviations are different. Why is that? So I'm going to go back up here and let's actually get looking at that Excel sheet. So this is what it is. I've already set up the table here to make it easier for you guys. Like I said, we're going to be calculating the mean and standard deviation for all the crimes listed. So I figured, well, let's just set up a table so they have a perfect little place to go. Like it was for last activity, I do not need you to submit to me the Excel sheet. I only need the Word document. So don't worry about submitting the Excel sheet as well when submitting the activity. Okay. So we need to find the mean and standard deviation for all of these crimes. I will do the first 5, and then I will leave it up to you guys to finish the remaining 5 on your own. I just don't want to be sitting here doing Excel, waiting for you guys to do Excel the whole time, because I feel like that's a waste of time. If you have questions, of course, that's not a waste of time, but I feel like once you do one correctly, you know how to do the rest of them correctly. But let's start. So we need to find the mean and standard deviation. So we're going to start with hacking and start calculating the mean. So of course, just like I mentioned last week, that equal sign in Excel is essentially us saying, hey, Siri to Excel, and it's just waiting for us to give it some sort of command. So equal, and then I start typing in average. Then I hit tab just to get that to pop up. And now I'm just going to select all the numbers for hacking, all of the participants' responses to their fear levels of hacking. And just like last time as well, each row represents one person. So this particular individual, this gentleman here, they had a high level of hacking at 10, 7 for panhandling. He said his fear of assault was a 10, breaking while away was a 10, murder was a 10, being conned was a 10. This is a very fearful individual here. Robbery was a 10, vandalism was a 10, breaking while home was a 10, and car theft was a 10. That was this particular individual. And then the next person, you'll see their responses to the fear levels for each crime there. Okay, so I have my average. I'm hitting tab 6.33. Now to calculate standard deviation. So this requires another function in Excel as well. It's calculated the same way as the average was, just by selecting the numbers we want to find the standard deviation for, except of course we're looking for standard deviation, not mean. yeah, I wouldn't be surprised if that individual was in Fresno either. Although they're not very afraid of panhandling. And if you've ever been around River Park and seen the signs that are like, say no to panhandling, whoever made those signs is definitely a 10 for their fear levels of panhandling. Alrighty, so now to calculate standard deviation. Oh, and by the way, I feel like I'm going relatively quickly, but if at any point you need clarification or need me to go over something, do not hesitate to interrupt me or put a message in the chat or something. I'm not going to be offended. I want to answer questions you have, but I need to know what those questions are before I answer. But I'm just going to kind of go forward. But if you need to stop me, don't hesitate to do so. Okay. I never know where to put the faces for Zoom. They're always in the way. There we go. Okay. So now we want to do standard deviation. So what I'll do is have the equal sign set up, of course, and start typing in Saint Dev, S-T-D-E-V. We'll have a couple options here. Well, these first two are really what I'm focused on. The rest of them don't pay attention to. Type in STD, and then the first two things you're going to need are here. Now, one of them is stdev.p, and the other is stdev.s. Now, the difference between these two, as their name kind of symbolizes, is the fact that stdev.p is population standard deviation, and .s is sample standard deviation. Now, before we start clicking, it's like, oh, it doesn't matter. Let's just find one. Let's just go for it. No, it does matter. What we have to do, though, to determine, oh, crap, which one do we need, the population or the standard deviation, is we have to, I know, I'm just getting out of you. We need to go back to the problem. We need to see if the data set that we have here is actually a population data set or a sample data set. So we go back to the problem, and we see that a researcher wanted to determine what the most feared crimes were among college students. So to define a population, it's pretty much the group, no matter how large or how small, it is the group of individuals. Doesn't always have to be people, but in this case it is. So it's the group of individuals in which we're interested in finding out this information for. This researcher wants to determine the most feared crimes among college students. College students is this researcher's population. That's the group of individuals that they want to know what the most feared crimes are. And then to obtain some data, they sampled 116 of their students. So that word right there, they sampled, is kind of a little giveaway that these 116 people in our Excel data sheet are a sample. So when you're reading problems in this class, when you're looking through a problem to determine which statistics need to be used, or just if it's a population or a sample, look for the number. Look for that 116 or 50 or 1,000 or whatever that number may be. And if it's saying something like it is here where, oh, we're interested in college students, but we're only looking at these 116, you know, they give you the whole pie here of the they give you the population pie. and then a slice a la mode of students for the sample? Or are they just saying, I want to know the most feared crimes among these 116 college students, and that is it? If that was how this question was worded, that would be a population, but it's not. So we have our population stated as the college students. And when we're actually dealing with our data set of 116, we would be using sample calculations. So we would be using sample standard deviation. Simple as that. All right. So we skiddly undo back over to the Excel worksheet. And now we know, okay, so this is a sample of 116 college students. Oops, I started doing average. So now we go back to where we were before, stdev.p and then stdev.s. And we know this is a sample, so we're going to go with the .s option. But as far as calculating it is concerned, it's still done the exact same way we calculated the mean of hacking. I'm just clicking and dragging all the way down from the first person, that incredibly fearful gentleman, to the last person. And we have our our sample standard deviation of 3.50. Now, I'm going to do a bit of a shortcut for Excel because it's a lot faster. And frankly, I get tired of dragging all the way down. So what I'm going to do is, I know that all the participants' data, all the numbers that we're calculating for, start at row 2. You'll see that, row 2 is the first one that's there. And the last one is row 117. 117 is the last. So what I'm going to do is just over here, because I can be incredibly forgetful. Oops, that's a 117, not 177. I meant to write there. Okay. So what I'm doing is I'm just writing what the row numbers are. Now, the exact titles are going to change. The letters before them will change based on the different crimes. You'll see that hacking is in column C, panhandling is in column D, assault E, etc. So when we calculated the mean for hacking, we went C for column C, 2 to C17. Again, the first representation of the hacking fear and the last at C17. Well, now we're going to do the same thing for panhandling. We'll do average, okay. Now, though, instead of typing in C, it's in column D. So I'm going to put D2, and you'll see Excel already is like, oh, this is what you're looking for, isn't it? Yes, it is. Then put a colon. Make sure you put a colon and not a comma or a period or anything else. A colon is what we need. And then do D117. And you'll see by typing that, again, the blue part here that Excel highlights is this what you wanted? And double checking, yes, Excel, that is what I wanted. Thank you very much. So that's a little faster way to calculate, especially since it's going to be the same. The only thing that's going to change as we move further down the line is just the column letter. But the numbers that we're using are exactly the same as far as the 2 to 17. Okay, so like I said, I'm going to do the first few of these. So we were doing standard deviation for a sample. I'm so sorry, my nose itches. I think there's a cat hair in it. Petunia, I blame you. But we have standard deviation for the sample. And then we're doing column D for panhandling, D2 to D117. All righty. And I'm going to go up to murder. Jeez. Okay, so E2 to E117, boom, standard dev.s, and then E2 to E117. Okay, so again, I like to double check because sometimes I feel like, did I type E there? It's kind of like when you leave the house and you're thinking, did I lock the door? You know you did, but you still double check. Yep, okay. So again, breaking while away, same concept, except now we've moved on to column F. So F2 to F117. Again, the colon is what we're looking for there. And of course, if you prefer not to use the method I'm doing and you prefer the click and drag method, go for it, whatever you're most comfortable with. Um, dev.s, and then where are we? Break in while away. So F2 to F117. And then I'll finish my little thing on murder. And then dot S and G2 to G1. Oops, G117. Good game, murder. Good game. Okay, so all righty. G2, G2, F2, E2, D2, F2, D2, C2. Okay. We have, you guys will do the remaining on your own. But like I said, I really wanted to focus on those last couple of questions in the activity. And we have enough here, enough calculations here for us to kind of get an idea of a better way to answer those questions. So before we get into that though, does anyone have any questions pertaining to any of the Excel calculations we did? Do you need me to show you again? Are there any questions, anything that needs to be addressed right now before we go forward? Good, we good? Okie dokie. Alrighty, so now let's go back to the Excel, or this is the Excel sheet. Let's go back to the in-class activity. So just like the homework, I will want you guys to round these to 2 decimal places like I have here as an example. So make sure that you round it to the nearest hundredth or 2 decimal places for all of them. Again, we've done the first 5. But you'll still need to put the means and standard deviations for those first 5, as well as, oh my gosh, excuse me, as well as the remaining crimes. Now, these first 2 questions we can't complete until we've done all of it. The question is asking which crime had the largest variability of responses and which crime had the smallest variability of responses. In other words, what do you think I'm asking here? What am I asking for when I'm saying what had the largest variability? What would you be looking at when I ask? Come on. I know you want to get it. Not necessarily the most outliers, although that could be a contributing factor to changes in variability. Right, the standard deviation. Standard deviation is a measure of variability, how much dispersion there is within a data set. And the reason why we can't answer right now with, at least I can't because I haven't completed it. Again, like I said, you guys will finish this on your own. And I've given you the tools and the knowledge to do so. But yeah, this question is just asking which crime had the largest standard deviation, which crime had the smallest standard deviation. So when you're doing this when you finish this on your own, make sure that you complete those 2 questions as well. But yeah, that's just what those 2 things are referring to. But now we move on to the really the heart of this activity, where I really want to focus on is how would the variability of all crimes change if we were measuring a population, and why would it be different? So what would happen if we were looking at a population standard deviation instead? How would it change those standard deviations we have now? Okay. So let's see. Oh, why did the reacts get in the way of the message? Dang it. So would it be higher due to a greater number of responses and likely a higher variability of those responses? I think that's the default. I think that's where our brain wants to go. Oh, populations are larger, so the variability would be larger as well. But actually, the reverse is true. Our measure of variability will be smaller when measuring a population. Even if we use the exact same numbers, the same 116 people and all their levels of crime, just like we already did, if we were to calculate the population standard deviation for each of those crimes, they would all be smaller than the sample that we've calculated. So the variability is smaller for a population. Why would that be? First, let me ask this. What do we do with samples? Why do we take samples in research, in statistics, in psychological research, in biological research, anything? Why is it that we're taking samples and not the population? Mm-hmm. Right. So we have Fiona saying they should be representative of the population. Exactly right, as far as the sample is concerned. And we have it's difficult to measure populations because not everyone participates in the study. Right. So even if we were to if we were trying to gather data from Fresno State students, all Fresno State students currently attending, let's say there's, I don't know, 34,000. I don't know. I'm just winging it. But if there's 34,000 Fresno State students that we're trying to gather data from, well, we would need to reach out to them. We would need to send them an email or a message on Canvas or something saying, hey, can you participate in our study? We want to hear from you. I guarantee you that a lot of students would see that and then just delete the email without even responding. It's like, I'm not going to deal with this. I have class, or I was going to eat, or I just don't want to deal with this right now. So we can't, so then instantly, even if one person out of 34,000 decides, nah, I'm not going to do this, or one person deletes an email, that's not a population. Now we're dealing with samples. So populations are incredibly difficult to obtain, especially as we get larger. 34,000 is pretty small for a population size, considering that that our current activity is dealing with the population of college students. I don't know how many college students there are, hell, in California, let alone the United States or the entire world. So that would be impossible to gather all of the population data from. So we take samples instead of 116 or 50 or a million, I don't know, whatever your sample size is. And it's supposed to be representative of the population. We use that group of 116 to generalize their findings, not just to the 116 that we've gathered information from, but to the entire population that they're representing. Exactly. So we use samples to better understand, or to give us an understanding of the population. Okay, so when we have these samples, we obviously don't have the whole population. That's why it's called a sample to begin with. Again, if we had 39,999 students answer our hypothetical Fresno State survey, we're still missing, or 33,999, we're still missing one person. That's still a sample. It's a huge sample. It almost covers the whole population, but it's still a sample. Now, with the samples that we have representing the population as a whole, we kind of have to overestimate some things. We have to overestimate how high and how low the data goes. So when we have the variability for a population, we have everything we need right there. We don't have any missing data pieces. Everyone is accommodated for because we're measuring the population. So now thinking about that, why would the variability of this data set change if we were measuring a population? Why would it be smaller, that variability, when measuring a population? Right. We don't have to overestimate now. For when we have the population, we don't have to overestimate how high or how low the data goes. With a population, everything's right there in front of us. I like to use the example of like a fishing net when referring to why population and sample standard deviations are so different. If you're going to go fishing, I don't know. I don't go fishing. Clearly, I don't know enough about it. But let's say we're going to take a net and we're just going to, throw the net over the fish and reel them in that way because I don't have the patience for a fishing rod. I don't know. Well, imagine that for a population, the water is clear. We can see all of the fish in the water in front of us. It's a clear day. Maybe we're in Hawaii. I don't know. They have clear water out there. But we can see every single fish swimming around our boat, or if we're on land, standing on the beach, or I don't know. But we can see all of the fish for a population. We have access to the entire population. We see everything we need in front of us. So with that being the case, we're trying to catch as many fish as we can. We know exactly the size net we're going to need. Okay, this big, just go over these fish. I see them. Oh, I got them. Got them all. Got them in my net. Okay. But for a sample, imagine now it's still the same situation. We still want to get as many fish as we can. We have a net, but now the water is murky. Now we can't see all of the fish. We know they're there. We know maybe we feel them swimming around our feet, or we just see a little occasional splash here and there if we're on a boat, whatever. We know the fish are there. But now we don't know exactly where they are, how many there are. There could be 1,000,000 there. There can be one. We don't know. But since we can't see, instead of getting the fishing net that we can just put over the fish we see directly, imagine this is standard deviation for a population. We know exactly how far the data spreads. We see exactly how far apart the fish are swimming around, and we know how long or how wide or whatever that net needs to be, boom, for a population. But for a sample, we don't have that. The water is murky. We don't see everything there. So instead of going with that same size net we used before for the population, we're thinking, you know what? Let's go a little bigger. Let's kind of extend our net a little further, just in case there are some stragglers on the outside or something, or stragglers over here. Let's make sure our net is bigger to get all of the fish here. We still want to get all the fish, just with the sample in those murky waters, we need a bigger net. That is standard deviation. That's variability. So for a sample, since we don't have access to the entire population for one reason or another, the water's too murky, one person didn't respond to their email, what have you, then we would still just lift it, just have a bigger net. So is the overestimation shown in the STDEV.S equation as the sum of squares as divided by n minus 1, which gives a higher variable? Correct. So as far as the equations for standard deviation are concerned, you saw this week in our lecture that the population standard, well, technically variance, because then we do the square root of variance to get standard deviation, but the concept is still there. So to find the sample, we do that n minus 1, that sample size minus 1. When we're doing a population calculation, we just do population size, capital N, done. So this difference in the standard deviations, where population is going to be smaller than sample, is represented in the equation as well, where, you know, instead of calculating, you know, my goodness, I'm sorry. That n minus 1 for sample, we're dividing it by a smaller number slightly by subtracting 1, but that's going to make that piece smaller. Imagine cutting a pizza or a pie into 4 pieces versus cutting it into 3. Less pieces overall, 3. Each individual slice is going to be larger. So looking at the variance equation and then in turn standard deviation, when we do that n minus 1 for sample, we have less pieces and those pieces are larger. Hence, that is the equation reason. That is how the equation, the formula for variance and standard deviation for samples reflect that difference in their size based on population versus sample. Sample, given the same exact numbers, same size, same exact calculations, same values. If you calculate the sample standard deviation, it will always be larger than the population standard deviation, even if all the numbers are the exact same, even if you're using that same data set. So as far as now looking at the question itself, how would the variability of all crimes change if we're measuring the population? Well, we can start by saying, okay, well, we know that the variability is smaller in a population because, again, the net only needs to cover this many fish that I can see directly. And then why is that? Why is population variability smaller? Because we see everything that we're interested in. The entire data set is what we need. We're not having to overgeneralize like the sample has to. We don't have to overestimate how much dispersion there is in the water. We know exactly how much there is for a population. So the variability is smaller because we don't have to overestimate for anything. We have the exact estimation. It's no estimation. It's just right there in front of us. Oh my goodness, my nose is so itchy. I'm so sorry. I look like I have a drug problem, but I just have cats. Oh. So is that making sense for this question? I know sometimes understanding the difference between population and sample is relatively easy, or it's like, okay, I can understand that. But I think kind of going a step further and knowing how it really can apply statistically and how the variability is affected and why is really important. If I haven't already, I'll make a note to say that when I test you in this class, when we take our exams, I don't give a crap about formulas. It helps to know them, just like the comment of, oh, so that's why the formulas are different. Sample has n minus 1, and that means the numbers are going to get bigger. And then population just has n. There is no minus 1 there. So it's good to know that because the knowledge that we're learning is reflective in the formulas. However, again, when I test you, I'm not going to have a question that's like, tell me the formula for standard deviation. I don't care. I do not care. I want you to know it because we'll calculate it, but you can know it by having it right beside you as you do your homework, or hell, even as you're doing your exam. That's not the question I want answered. I'm going to want to know this kind of stuff. How would the variability change and why? Not just what's the formula, but why is this happening? What's the what's going on behind the scenes here. All righty. So moving on to the next question. The range of each crime is 9, yet all the standard deviations are different. Explain why. So I want to start this by prefacing that, well, actually, I first want to ask, how do we calculate range? What do we do to find the range of a data set? What do we need to do? Right. The largest value in the data set minus the smallest. Now, if you remember from the description of this data set before, it was saying that all the fear levels were on a 1 to 10 scale, where 1 was the lowest amount and 10 was the highest amount that someone can rate a particular crime. So the range of each crime is 9. So the range for hacking is 9, for panhandling, assault, murder, robbery, etc. All of the crimes have a range of 9. So we know that's telling us that's at least one person for each of those crimes. And it's probably most likely that first person, that poor scaredy cat guy. At least one person rated the crime as a 10. Oh my God, holy moly, I am terrified of panhandling. Well, no, he wasn't terrified of panhandling, but at least one person for each crime rated it a 10. And then at least one person for each crime rated it as a 1. That's what this part is telling us. The range of each crime is 9. That means for each crime, someone put 10 and someone else put 1. Yet all the standard deviations are different. Just from the 5 calculations that we've done together as a class, and of course, if you've done all of them, awesome, good on you. But just from the 5 we've done together as a class up to this point, we see that all the standard deviations are different. And just as a reminder, we'll see we have a 3.5, 2.6, 2.71, 2.84, 3.26. So while the ranges for everything are 9, they're all identical. And keep in mind that range is a measure of variability. So that measure of variability for range is identical across the board. Yet here, just in the 5 we've done so far, they're all different. So why is that? Why is the range all the same, but standard deviation isn't? Why is this measure of variability all equal, but then this one has so much variability? How can we describe that? How can we explain it? What are some ideas we have? Exactly. So for range, we only have the highest and the lowest. A lot of us are kind of phoning in with that response. Excellent. We're getting it. Range only takes into account the big and the small. That's it. With this data set of 116, range leaves out 114 people. They're not important for this measure of variability. I'll tell you the variability, it's 9 because I'm doing range. Then you have standard deviation, which accounts for all of the people, not just the highest and the lowest person's amount of fear. Ow, that was my side. Not just the highest and the lowest person's level of fear, but every single person of those 116 or 50,000, or again, whatever your data set is, standard deviation is looking into all of those people. So while range again is a measure of variability, it is not nearly as insightful and doesn't give us nearly the same information as the standard deviation. Because really the range of each crime being 9 really boils down to, just like I said, it's on a 1 to 10 scale. So the highest can only be 10 and the lowest can only be 1. And with the range of these crimes being 9, that means at least one person had the highest and at least one person had the lowest. That's why the range is 9. But then why are the standard deviations different? We know it accommodates for all of the data, not just the top and bottom one. But why would the standard deviations vary so much from crime to crime? Keep in mind that standard deviation is a measure of dispersion within a data set, how close to the mean our scores are. The closer to 0 the standard deviation gets from the ones we've calculated so far, this standard deviation for panhandling is the closest to 0 at 2.6. The closer to 0 our standard deviation gets, the closer to the mean that those responses of 116 are. And the further from 0 it gets, so, you know, each score gets a little higher, that's showing that each of those kind of stray further and further from their respective mean. So why would there be different dispersions for these different crimes? Right. Because each of these crimes are different for each person. You have this gentleman, this first guy here, who's terrified of everything, but not as much of panhandling. You have the next person, meh, I don't really care about hacking. It's not really on my radar. In fact, they're kind of just meh all the way around. They're fearless down here, while as this guy up here is terrified. Then you think about, you know, these are college students, and obviously college students has a range of demographics. And I'm not a college student, but just kind of thinking personally, just from person to person, our fear of crimes change. I'm a woman, so I might have more fear of particular crimes than perhaps my male counterpart, but I'm also white. So there's going to be privileges that I have that maybe there's crimes that I'm not nearly as conscious or afraid of as an individual of color would be. Just in that small instance, I say small, but that constitutes a huge range of variability right there. Just people aren't going to have the same fear of crimes. They're not going to be the same from one person to the next based on individual experiences, based on maybe, oh man, I've been watching a lot of, you know, true crime documentaries, so now I'm terrified of being murdered, or I don't know, whatever the case may be. But all of these standard deviations are different. All of these standard deviations are reflecting the variability, how some people are really afraid of murder and some people maybe not so much. And that the larger that variability is, the more kind of back and forth there are. There's probably going to be a lot more scores for panhandling, with that being having the lowest standard deviation I have represented here. There's going to be a lot more scores for panhandling that are closer to that 5.04 region in comparison to hacking. There's 6.33 with the highest standard deviation here in comparison to all the others we have. This crime and its data set is going to have a more variability overall. You're going to see some more 10s and 2s and, you know, kind of all over the place. They're not all going to be as close to the mean of about 6 as, let's say, panhandling is. The data will be still closer to that 5.04 to its mean than any other here. So yeah, the reason why the ranges are the same because they're using the same scale. All of them are using this 1 to 10 And for each crime, like we see here, boom, right there. Those are the two scores for breaking while away. We got a 1 and a 10. We got a 10 here, and we got a 1 right there for assault. We have a 1 and a 10 here. We have a 10 and a 1 right there. You'll notice though that when we're looking for that at a data, when we're looking for the range of a data set, we're really just looking for 2. Like, oh, 1, there's my 10 right there for murder. Oh, and here's my 1. Done. Moving on to the next one. Here's my 10, here's my 10, here's my 1, done. Here's my 1, here's my 10, done. Hardly any real calculations are occurring. But then for standard deviation, it's all of it, every single one. And like I said, with that accommodation for all of the data set, it provides us a better insight into how much variability is there in the fear of hacking. Hacking of the crimes we have represented here has the most variability. Some people are really afraid, some people aren't so much. And it has the furthest stray from the mean represented of all the crimes here. So yeah, that concludes the activity, at least what I'm going to do with you guys. Again, make sure that you do the remaining, this question, the largest and the smallest, and of course, finish the calculations. But do we have any questions about the conversation we had regarding the range and the standard deviation, or the population versus the sample? Any questions we have before we conclude our meeting today? Here, let me do full face. There we go. All righty. Well, of course, if you have questions, don't hesitate to message me on Canvas. I have recorded this meeting, so it'll be up as soon as my internet can get it going. I know last week it was pretty quick, but it's not always like that. Sometimes YouTube, it takes a while, or downloading it from Zoom takes a while. But the video will be available in this week's module, in case you want to look over it again. Or, of course, for those people who didn't show up today, they can see that as well. But until then, let me see. I don't know. Let me double check. I'm checking our class Zoom meeting schedule to see if we have a meeting next week, and we do, for in-class activity 3. Okay. So I will see you next Friday at noon. Until then, take care of yourselves. Have a good week. A good weekend. And I'll see you next week. Bye, everybody.